So we're going to look at some symmetry tests here for polar equations and polar graphs. So a polar equation describes a curve on the polar grid. The graph of a polar equation can be evaluated for three types of symmetry as shown below. So it could be symmetrical with respect to pi over 2, symmetrical with respect to the pole 0, and it could be symmetrical or reflected across here. So here's how we test for the types of symmetry. Substitute the appropriate combination of components for r theta. And it's like that, there. And so negative r, negative theta, for the pi, theta being pi over 2. Here. For that symmetry, and r and negative theta for polar axis symmetry, and so that was r negative theta versus negative r positive theta for symmetry with respect to the pole. Okay. If the resulting equations are equivalent in one or more of the tests, the graph produces the expected symmetry. So we're going to look at testing for r equals 2 sine theta. So let's see, if we said negative r equals 2 sine of negative theta, then we'd have negative r equals, and so this negative can come through, negative 2 sine theta. And so dividing out the negatives, we get r equals 2 sine theta. So this has symmetry with respect to theta is pi over 2. Now let's try the next one. R equals 2 sine of negative theta. So that'd be r equals negative 2 sine of theta. And that's not the same thing as 2 sine theta. So this fails. So no symmetry for theta equals, what do we say, or symmetry with respect to the polar axis. And then r equals, or negative r is 2 sine theta. And that's just not going to be the same thing. So like r equals negative 2 sine theta like we saw in the last one. So no symmetry. So let me just clarify. This one was polar axis. And this one is with respect to the pole. Okay, and that's it for this video.